Hello everyone, this is Dr. Nemai Karmakar. I am from the Department of Electrical and Computer Systems Engineering, Monash University, Clayton, Victoria, Australia 3800. I can be contacted via the following email address. The title of my talk today is Chipless RFID, New Paradigm in Radio Frequency Identification System. Today I am going to talk about my pioneering work on chipless RFID that I have been doing for the last 12 years at Monash University. The outline of my presentation is as follows. Part 1, RFID and its applications. Part 2, chipless RFIDs, new paradigm tags. And Part 3, applications of the chipless RFIDs. In Part 1, I shall briefly define RFID technology in layman's perspective. Then I shall give you some exciting applications of RFID as the disruptive technology in identification, tracking and tracing. Then I shall give you some statistics why we need to have chipless RFID to make the RFID viable for mass deployment. In Part 3, I shall define the chipless RFIDs, new paradigm tags, various chipless RFID tags developed in my laboratory will also be presented, followed by chipless RFID applications in Part 3. I shall conclude my presentation with some inferences and important findings. RFID stands for radio frequency identification. It is one of the disruptive technologies in the modern decades. It is one of the most discussed technologies as well. It has unlimited applications. An RFID has three main components: a tag and a reader and a middleware. The tag and the reader fall in the physical layer or hardware part. The middleware and the enterprise software fall in IT layer. The tag contains the identification data. The tag has an application-specific integrated circuit, in short ASIC, ASIC, and an antenna. The ASIC is the culprit that makes the tag expensive and uncompetitive for mass deployment. The reader is comprised of an antenna and an RF transceiver. The middleware controls the transceiver electronics, processes the identification data, and interprets with the meaningful identification codes. Finally, interfaces with the enterprise software or the World Wide Web. We use RFID in our everyday life. Car immobilizers are vivid examples of RFID application. The photograph shows a near field, also called magnetically coupled, chipped RFID tag. The rectangular coil antenna couples magnetic field, also called H field, with the reader coil antenna. Thus, wireless communication is established. The ASIC does all modulation and demodulation of the RF signal and transmits unique ID to the reader, and that is further processed in middleware. This type of near field tags operate in 13.56 MHz and is the dominant candidate in the RFID market. The total revenue of the chipped RFID market is $17.6 billion in 2006. This graph shows a very interesting trend of chipless RFID by the UK-based respected research institution ID TechX. However, the forecast could not be materialized due to the very high price of tags. The vision is to access the RFID technology from expensive to low cost mass deployable items in retail stores. If you see the current implementation of the RFID technology with the forecast, we are at least 10 years behind. Why? This is due to the fact that the cost of the tag is so high and the technology is not matured enough to address the high cost issues. Due to the silicon chip in the tag, the cost per tag cannot be down to less than 5 to 10 cents. We are hanging at 5 to 10 cents if we buy tags in billions. The big ambition of Walmart to implement RFID in their supply chain is a big failure due to the cost of the tag. With the telemarketing and e-commerce, parcels are the main revenue generator for the Australian postal system. However, the same issue of cost hindered the RFID implementation. Super dollars, counterfeiting of currencies. Currency counterfeiting is a big problem worldwide. RFID can stop counterfeiting. My research funds mainly come from the Australian banknote manufacturing company Innuvia Security International. They find potentials in the chipless RFID as the strong technology to beat counterfeiting. Left-hand photo shows fake dollar bills. According to Wikipedia, over $35 million of $100 bills are produced by British criminals and were arrested in 2012. In 2003, Greek authorities were confronted with 2,411 counterfeiting cases and seized 4,776 counterfeit banknotes, while authorities in Poland nabbed a gang suspected of making and putting over a million fake euros into circulations. Money laundering was also an issue of increasing concern, and that was probably one of the reasons that the higher denominations were considered for tagging. Here, $200 and $500 euro notes are shown grain-size chipped RFID tag, but obviously the cost of the tag is more than the currency itself. Significance of RFID can be observed in the bar graph. This indicates a steady growth of RFID technology. But one contrasting part is that RFID tag price is stagnant at a certain level, say 10 cents lowest. Why? This is because the cost of the chip attached to the tag. Until we remove the microchip from the tag, we cannot offer low-cost tagging and tracing technologies. Until that time, optical barcode will dominate the market. Remember, a quick read or QR code can accommodate kilobytes of data. In the next slide, I shall show you the future trend of RFID and its cost target and associated volume of sales. RFID forecast. Very interesting graph. The red curve shows the predicted trends of tag price over the year until 2020, and the bottom dotted curve shows the ideal situation that we desire to have about the tag. Until we can make the tag less than a cent, we cannot attract its application in mass deployment such as retail items and perishable products. With only printed tags like optical barcode, we can offer competitive technology that can be printed directly on the paper or plastic packaging. We have been working in this fully printable chipless RFID tag technology for the last 12 years at Monash University. We have tremendous successes in the Printed tag technology. We have published 8 different books, 15 PhD student graduations, 8 patent applications, and over 200 journal, conference, and workshop publications. Essentials of chipless RFID. This is an old prediction by IDTechX that about 40 to 60% tag market will occupy the chipless RFID tags. However, this is still a dream due to the technological difficulties and the cost associated. Only commercially successful chipless RFID tags are the radio frequency surface acoustic wave tag. However, RF SAW cost about $2 per tag due to special fabrication processes and SAW materials. It is non-printable and bulky. The next chipless RFID tag is thin film transistor circuit, in short TFTC tags at high frequency band. They are also expensive and cost around 10 cents if purchased in millions. In the next section, I shall present the paradigm fully printable chipless RFID tags.